Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to provide some examples of applying the chain rule here, the chain rule differentiation. So we're going to look at these three examples and calculate derivatives for each, starting with this animal here. So if y is equal to the square root of 3x squared minus 4x plus 6, and we want to differentiate it, that is, we want to find y prime here, there's a couple different things that are going on here. You have this polynomial looking thing inside of here, and that's one function, but you also have this square root function applied to the outside. And when you differentiate, you typically work outside in. So we're going to start with the square root function, which, remember, as a power, this would equal 3x squared minus 4x plus 6 to the 1/2 power. So when we differentiate the outer function, we're going to have 1/2 times 3x squared minus 4x plus 6 to the minus 1/2. That's what you get when you take the power of 1/2, multiply, subtract 1 from the power. All right, now here's where the chain rule part comes in. Now we have to differentiate the inner function, and this thing's derivative is going to be 6x to the first minus 4, and the derivative of a constant is 0. So that's done. I'm not going to worry about simplifying or any sort of cosmetic things here. I'm just going to talk about the differentiation process. All right, second example here, y equals 5 cosine to the minus 4th of x. So when we take the derivative of this, the 5 is a constant. Again, the two functions here, the cosine function is the inner function, and then to the minus 4, that's a power function. We'll differentiate the power function first. So by the time we bring down the power, we're going to have minus 20, because there's a 5 sitting in front of it, times cosine x to the minus 5th. Remember, you subtract 1 from your power. So now the outer function is differentiated, and then we'll differentiate the inside function. Derivative of cosine x is minus sine x. And I'm not going to worry about any sort of cleanup or simplification. The purpose of this video is just how to differentiate. All right, this example, let's see if we can get this in this line. Oops. All right, so now if we want to try to differentiate this function, let's start with this thing. Outer function is the minus 3. So the derivative of that, we're going to bring down our power, times 5 minus 2x to the minus 4. All right, so this function has been differentiated. Now we differentiate the inside function, so that's going to be times minus 2. Now that's just the first half of this. We also have this to deal with. Inner function is this 2 over x plus 1. Outer function is a power function, something to the 4th power. So we're going to differentiate the outer function first. So you bring down the 4. That's going to make this a 1/2 times this quantity in the parentheses to the 3rd power. Okay, times. Now we differentiate the inside function, treating this like 2x to the minus 1. I'm going to write that right above it. Its derivative is going to be minus 2x to the minus 2 by the time you bring down the power and then subtract 1. The constant's derivative is 0. So that's done. So here's three examples of applying the chain rule. None of them are simplified or changed cosmetically in any way, shape, or form. Just focusing on the differentiation process for all three functions. It's just important that when you're looking at a function composition, you recognize it as such, and then make sure both functions get differentiated via the product rule. And again, like for example, here the inner function is this polynomial looking thing, outer function is this power, something to the 1/2. Here the inner function is cosine, outer function is this power deal to the minus 1/4, and so forth. So I hope that this video has helped provide you with good examples of how to apply the chain rule differentiation. Have a great day.